Hello everyone, welcome back. So in this video we are going to understand the LeetCode problem number 3719. It is a longest balanced subarray 1, and this problem is little in the wrong sense. We can say that the most people get this problem wrong because they forget one dangerous word called distinct. As you can see, we have written that we have given us array and subarray called balance if the number of distinct even numbers in the subarray is equal to the number of distinct odd numbers, right? It means why they forget these dangerous first distinct, because they think that this is between the even and odd count, right? It's easy, right? But what is wrong here? It's not about the total count, right? It's about the distinct value. Okay, so let's suppose if you are going to see this problem, this example, right? If you see that you are saying that the problem is says between the even and odd number or even or odd count, but the problem is that here we have not distinct element. These are two different element. These are two same element. We have distinct element. It's not a different element, right? Because 2 is coming 2 times means it's a duplicate value. But it is saying about the, if you're finding the count, you have to find the distinct. Okay, so we'll understand the very first the problem we'll understand, and then we'll see the changes that we have to make, and I'll show you how to implement this type of problem. So today I'll show you the simple way to think about it, the how the pointer works in this type of problems, right? Pointer concept works in this problem, and we'll try to understand the clean Java implementation and why sliding window can trick this type of problems. Okay, so very first what we have given here is we have given an array integer, and a subarray is called balanced, right? If the number of distinct even numbers and number of distinct odd numbers both we have given, and if it is equal, if their counts are equal, number of distinct even numbers and number of distinct odd numbers both are equal, right? So we must return the longest balanced subarray, length of longest balanced substring we have to return. The important things matter is distinct matters here, right? And why we am saying that this distinct matters here, because distinct matters means duplicate don't increase the count. Okay, so if you come here to the constraint, right? If you see the constraint, it can be up to 1500 elements or in the nums. Okay, so the constraint is very high here. That's the first clue we have given here. When n is small, it will take off n square and it is acceptable. But if you think like this, right, if you see the constraint here, so don't overcomplicate it, because if you're taking off n square, right, because n is a small, right, and we know that O of n square is acceptable here, right? But still we should optimize our code. Okay. Okay, let me zoom out a little bit. Okay, so let's suppose we have given these nums we have given is 2, 2, 5, 4, 3, and the even numbers are here 2 and 4. These 2 and 4 are even number, right? And so can we say that if this type of problem happens, right, the even numbers we can collect one side, 2 and 4. How many numbers are there? 2 numbers are there, and 5, 3 is odd number. So if you see here, it has 2 distinct even numbers and 2 distinct odd numbers, right? It means it is balanced, right? Because the count is 2 here, 2 distinct even and 2 distinct odd number, right? So both are same, and so this is balanced one. So the complete string, the complete given string itself is just balanced substring, balanced subarray, you can say, not substring, balanced subarray. The given subarray itself is a balanced subarray, and that is why we will find the length of this subarray that there is the whole elements are coming, it is 4, and so the answer is coming 4. Okay, but if you come down here, so you see this one, the last one. If you see this one, 1 2 3 2, here the count of the even numbers is 2, but the problem is that this is not distinct, right? So distinct, if you'll take here, it is 1 number, so because there is only one even number, 2 is repeating 2 times, right? So if we check the full array, right, so you will find the distinct even number, which is coming only on 1 as a 2, count is 1, and that is why we say 1 distinct even number. Similarly, we have the distinct odd number, it is 1 3, right, as a 1 and 3. Okay, so there is 2 count is there, right? So it is not balanced. It means we have to find a different substring. So let's suppose the very first element, if you will not count, the rest of the element is 3, 2 3 2, right? So if you'll take this sub array, and then if you'll find the distinct even number count, it is coming 1, and if you'll take the distinct odd number, it is coming 1. So if we'll take this substring, it is a longest balanced subarray, and so the answer is coming is 3. Okay, because the length of this subarray is 3. It was not balanced, but we have to find the balanced one, it is balanced or not. So if we'll take full array, it is not balanced, but if we'll take the substring, right, this is a balanced one. Okay, so we explore the subarrays, right? We explore the subarrays, and then we find the balance or not balance. So very first, that let me show you the code. Okay, so very first we fix a pointer, let's call I here, and let me zoom out a little bit. Okay, so very first we will fix the pointer, let's call the left pointer. Let's start from 0 to n. So because we are going for the sliding window, right, because we have to expand the right pointer also. So we'll take 0 to n, and then we'll take the right pointer, right? So let's suppose j will say I to jn will go, and we'll take one element at a time, and we will find the substring, right? So to find that, you just need to do what? You have to find the element, the frequency is already there or not. So we have created the frequency map, distinct count, distinct even, like that we have created. Okay, so basically the core problem here is, like, if you talk about the intuition, right, this is not a prefix sum problem, not typically a sliding window, guys, right, not a parity counting. Okay, so it's about tracking distinct value dynamically. We are tracking that distinct value here dynamically, and if you see here, that is why we have taken the frequency map, right, and we'll check if it is there or not, what is the count is here. If we'll find the value on the map, will increase its count, right? So we want to track the distinct value dynamically, and so we will keep here the frequency of each element. Okay, basically it means that we will use a hash map to track the frequency. When frequency becomes 1, it is a distinct element, right? Very first time it is coming, it is a distinct element, it is 1. Otherwise we will update its its count, you can say. Okay, its count will increase. We'll also take 2 other variables, distinct, even and odd. So very first we'll check the, if it is even, will increase the plus plus, otherwise increase the odd plus plus. So in this case we will update even or odd count, and we'll check further if it is balanced or not. If it is balanced, we'll find these elements are on the you can say, due to the substring length, right? We need the substring length, so we will find the max substring length, which is balanced, right, and we'll return this max length finally. It is very easy, guys, right? What we are doing is that each element we will store on the frequency. We'll have the frequency of each element, right? So we'll take 2 pointers, I and j, correct? I and j will take. Each element will check. Each element should be on the frequency. If it is coming with the very first time, its frequency will be 1. Otherwise, its frequency will get added over the frequency count, that this is not distinct element. It will increase plus 1 2 3 like that. It will get added on each element, right? Then you will check that element frequency, if it is equal to 1 means this comes for very first time. Check it is even. If it is even, increase the count even, otherwise odd increase. Then we'll keep checking with each element, right? Very first element came, let's suppose 2, 3, 4 like that. So for each element you will find the distinct is it is balanced or not balanced. If it is balanced, the rest of element you will start from j to I, j minus I plus 1 you will do, and you will find the length here. And finally you will track the max length, and you will increase the max length if the balance is increasing. Otherwise you will track the max one and you will return the max length. समझ में आ रहा है ना? बहुत इजी है, कुछ नहीं करना है, मैक्स लेंथ लेना है यहाँ पे आपको, राइट? और एक फ्रीक्वेंसी मैप करके ले लेना है ताकि आपको की वैल्यू आप स्टोर कर सके. लेट्स सपोज की रहेगा आपका एलिमेंट रहेगा, और उसकी जो नंबर ऑफ काउंट रहेगा फ्रीक्वेंसी यू कैन से इज 0 से मतलब 1 से स्टार्ट हो रहा है, 1 2 3 4 लाइक दैट इट विल गो, मीन्स द अकरेंस कितना है वो हम स्टोर करेंगे. सो ईच एलिमेंट के बेस पे हम क्या करेंगे, हम एक सबस्ट्रिंग निकालना चाहते हैं, राइट? तो उसके लिए क्या करना पड़ेगा, सबसे पहले हम लोग चेक करेंगे. अगर ये फर्स्ट टाइम आ रहा है तो इसके अंदर जाएंगे, राइट? और चेक करेंगे ओके दिस इज अ डिस्टिंक्ट एलिमेंट. देखो डिस्टिंक्ट एलिमेंट का कॉन्सेप्ट यहीं से आ रहा है, ठीक है? अगर डिस्टिंक्ट एलिमेंट बना रखे हैं, राइट, फ्रीक्वेंसी डॉट गेट नम्स एट दिस मीन्स फ्रीक्वेंसी अगर तभी हम काउंट करेंगे, राइट? लेट्स सपोज कि वो डिस्टिंक्ट एलिमेंट है, और तब जाके उसको क्या देखेंगे, हमें चेक करना है कि डिस्टिंक्ट इवन नंबर और नंबर का काउंट सही है या नहीं. अगर इक्वल टू सेम है तो हम सबसे पहले हम लोग क्या करेंगे, ट्रैक करेंगे कि इस सबस्ट्रिंग का लेंथ क्या है. कैसे निकालोगे, j माइनस आई प्लस 1. तो आपको पता है कि i तो फिक्स है, j मूव कर रहा है तो j माइनस आई करेंगे प्लस 1, तो इससे आपको लेंथ मिल जाएगा सबस्ट्रिंग का. और उस सबस्ट्रिंग का लेंथ हमें चेक करेंगे, अगर मैक्सिमम है तो अपडेट कर देंगे मैक्स को ट्रैक, क्योंकि मैक्स को मैक्स लेंथ को ट्रैक करना है. सो दिस इज द वे गाइज वी implement this problem, right? So because the n is less than 1500, right, so O of n square will be acceptable because I and j we are taking. So n small है, it is इसलिए यहाँ पे क्या है, O of n square completely fine है. So smart engineer optimize only when it is necessary. Simple guys. So ऐसा नहीं कि आप हर चीज़ को optimize करने लगो, ठीक है? So why sliding window will fail, because you might think that can we shrink the window when invalid. So the problem, it is a balanced condition is not monotonic, okay? Adding elements can increase only odd count or increase count, only it will increase only the odd count or even count, we can say that, right? If you are adding the elements, right? So if you are removing the elements, it can reduce the distinct count, or unpredictably it will happen. Like, let's suppose if any elements you remove, simply you are disturbing this balance, correct? So the sliding window becomes messy here. So brute force is a cleaner and safer way here, so you can use like this brute force approach, and other approaches will not work like that, okay? So in the other approach, let's suppose you are trying with the prefix difference tracking, so it doesn't work because we need distinct elements, right? We have seen that, right? So because the distinct changes dynamically, right? If you are also using, let's suppose, the bit masking, the values will go up to 10 to the power 5, so that is also impossible to implement that, right? We have seen that the constraint, right? If you are trying to optimize this problem, right, optimize attempt you are trying to do, which is not required due to the constraint. So the moral of the story is, when you know the brute force is correct, right, that's the senior level thinking, you don't need to do further. So if you talk about the interview strategy, right, when you are seeing the subarray distinct count and n is less than 1500, what do you think? So whenever you see subarray distinct count and n less than 1500, I think fix the left first, right? First fix the left and expand the right. As simple as possible, you do this first two things you do, and maintain a frequency map that you are doing here like that, right? So you have to frequency map, you have to maintain it, right? And clear the deterministic reliable thing what we have given, and don't chase a fancy trick. Do the simple trick that we know how to find the even number and odd number concept like that, and you can implement. So if this explanation made this problem finally click for you guys. So please like this video, subscribe for more FAANG level DSA breakdown, and comment which problem you want in the next. That's all I have in this video, right? So remember, the clarity beats the complexity. I'll see you in the next one, and please write the comment section if you have any questions, and also do like, subscribe this channel and support ExpertFunda. In case you are struggling with DSA, you can join our online classes. Thank you. Bye bye.